Greetings and welcome. Let's take a look at our third example from week 8 from chapter 4 on integer programming. So in this screencast, we'll formulate our integer programming problem, and then we'll have a follow-up screencast in which I'll solve using LibreOffice Calc. Okay. But here we go. Oilco is considering 2 potential drilling sites for reaching 4 targets. The following table provides the preparation costs at each of the 2 sites and the cost of drilling from site I to target J. So we can potentially drill 2 oil wells, and then we need to connect those sites to 4 different targets. Okay, so each target needs to be hit once, either from site 1 or site 2. And we're given the cost to drill to all of our targets from site 1 and 2, and then the cost to prepare sites 1 and 2. So I know my goal is going to be to minimize my cost, okay, where my cost is going to be due to the cost of preparing sites 1 and 2, and then also the cost from connecting sites 1 and 2 to my targets. Okay, so as I think about this goal in terms of thinking about variables, then, okay, so the first thing I'm going to need is we'll have a binary variable again, and I'll call it y1 or y1 and y2, okay, which are going to be, take values of 1 or 0, and they'll indicate if the site is go or no go. Okay, so we need to have a variable indicating if we're going to, prepare site 1 and site 2. Okay, and then, okay, so we could prepare site 1 and site 2, and then we have to potentially connect site 1 and 2 to all 4 of our sites. Okay, so let's see, so if I have target 1, okay, so we'll have target 1, site 1, target 1, site 2, I'll have target 2, site 1, target 2, site 2, and then let's add into this target 3, site 1, target 3, site 2. Okay, and so this is going to be related to, if a target, I is connected, and I think I'm using so I've got to change my notation. If a target J is connected to site I, right? That's what Xij corresponds to. Okay. All right. So we're going to have a bunch of, essentially they're going to be, these binary variables that are going to take on values of 1 or 0. Okay, and it's going to indicate if we need to prepare site 1 or site 2, and then based on that, how we're going to connect our targets to those sites. Now remember, our targets only need to be connected to a single site. Okay, so we're going to take this piece by piece. Okay, so if I start with my objective, okay, my objective is going to be to minimize my cost. Okay, so I'm going to minimize z is equal to, okay, so my cost will be, so if you look at target 1, okay, so cost of connecting target 1 to site 1 is 2, okay, and this is in millions of dollars. So I'll write this as 211 plus 4 x12 in my notation plus 1 x21 plus 6 sorry, pen, plus 6x22 plus 8x, and actually I forgot we have x41 and x42. There's 4 targets, so we have 8 x31 plus 3x32 plus 5x41 plus 1x42 plus we have the costs of preparing our 2 sites, so I'll have 5y1 plus 6 y2. Okay, so there's our objective function we want to minimize. So basically it's the cost of connecting all of our targets to either site 1 or site 2, then the cost of pairing site 1 or 2. Okay, but now we need to get into our constraints. Okay, so the big one's going to be if I have 2 sites, okay, and I have 4 targets. Okay, so let me try and draw a picture. So let me call this site 1. Here's site 2. Okay, and in my sketch, I'm going to create targets 1, 2, 3, 4. Okay, so if, for example, site or target 1 can either be connected to site 1 or site 2, but not both. All right, so if, for example, it's connected to site 2, then it doesn't need to be connected by site 1. Okay, it could repeat for site 2. Site 2 could be connected, or target 2 could be connected to site 1 or 2, but if, say, it's connected to site 1, then it doesn't need to be connected to site 2. Okay, and so on and so forth. Okay, so how I'm going to write this constraint is, remember, these are all going to be binary variables. They're all going to be 1 or 0. Okay, so y1 will be 1 if I'm going to prepare site 1, 0 if I don't. y2 is going to be 1 if I prepare site 2, 0 if I don't. These x variables, right, x11 will be 1 if I connect site 1 to target 1, 0 if I don't. All right, but if I don't connect site 1 or target 1 to site 1, then I need to connect it to site 2. So how I'm going to write this up is, let me give it a try and let's see if it makes sense. So when I go through my constraints, I'm going to write y1 x11 plus y2 x12 is equal to 1. Okay, so now remember, y1 and y2 can have values of 1 or 0. Okay, so let's say, for example, I prepare both sites 1 and 2. So if I prepare both sites 1 and 2, then those are both 1. Okay, but then I can only prepare or only connect, I'm only going to connect target 1 to site 1 or site 2. All right, so by restricting that, then the sum of these two have to be equal to 1, along with my integer constraint, then I'll be able to, I'll have my integer constraint, I'll have my non-negativity constraint, and then I'll have the x1 and x11 and x1. All my x's are going to be, all my variables are going to be less than 1, right, to force them to have those values of 0 or 1. Okay, so if, all my variables have limitations of values of 0 or 1, if, say, site 1 and site 2 are both prepared, those are both 1, and so then either one of these can be 1 but not both in order to satisfy this constraint. If I don't prepare, say, site 2 so it's 0, well, then I have to prepare or connect site 1 to target 1. Okay, so I'm going to write one of these down for every single case then. So I'll have y1 x1, well, that's site 1, so then target, or sorry, I'm getting jumbled up in all this jargon. So that's target 1. So if I go to target 2, okay, target 2 I can connect to site 1, or I can connect it to site 2. Target 3, okay, I can either connect that to site 1 or site 2. Target 4, I can connect to site 1 or site 2. Okay, so here's all my connection constraints. Okay, and again, I'm only going to connect a target to either site 1 or site 2 while minimizing my cost. Okay, next I'm going to write down our standard constraints. All right, so one will have non-negativity, and that'll apply to all of our variables. So we'll have y1, y2, x11, x12, x21, x22, x31, x32, x41, x42. Those all have to be greater than or equal to 0. Okay, so they're all going to be positive, greater than or equal to 0. I'm going to apply my integer constraint. So, I'll list all variables are integer, so I could copy all that down again if I wanted. So all variables are integers. Okay, and then the third one is, okay, the way we have this conceptually set up is all our variables are going to be binary, either 0 or 1. All right, so I could set that up in Solver, but how we're going to do it is we already have. So again, just for an example, so if I wanted to take some variable I, and I want to restrict that it is greater than or equal to 0 but less than or equal to 1, all right? So since I've already restricted my variables to be integers, if it has to be between 0 and 1, the only two values that could possibly satisfy this relationship are 0 or 1. Okay, I could decompose this into yi is greater than or equal to 0 and yi is less than or equal to 1, where this first one is already set by our non-negativity. Okay, so all that's left then is to fix all our variables to be less than or equal to 1. Okay, so we'll and I'll just say all variables, or I'll list them out again. So just like non-negativity, all of our variables, in addition to being non-negative, greater than or equal to 0, will be less than 1, 2, 2, 1, 2, 2. All of our variables will be are going to be less than or equal to 1. Okay, so that's it. So we're going to minimize our cost, which is composed of preparing sites 1 and 2, and then connecting our targets to our sites. Okay, but all these variables are binary. Either we prepare site 1 or we don't. Either we prepare site 2 or we don't. Either we connect site 1 to target 1, or we connect it to target 2. So our constraints should be set up in this way, in that if my connection variables are positive, well, then they need to sum to 1. Only one could be 1, the other has to be 0. And by multiplying by whether or not we prepare site 1 or 2, then we're going to automate this. If I don't prepare site 1, then I can't connect target 1 to site 1. Okay, but that's it. I'll stop this video and we'll go over and we'll solve in LibreOffice Calc. Hope that helps.